All right. So on the front side of the review, starting with 4-1, column 1 there, 1 through 6. This whole side was all about segments using number lines. So on the first one, given line segment GH lies on a number line and coordinate G is at 52, if the length of GH is 17, what are the possible coordinates of H? So this is the distance that we have. The two coordinates are away from each other. Now, distance does not show whether it's positive or negative, right? What direction it goes in. So we have to go both a positive and negative direction from the original point. So you could draw a number line if you need to, but all you're doing is starting from 52. You'd have to either add 17 or subtract 17 to find your other number. So if you add 17, you'd be at, let's see, that'd be 9, that'd be 6, 69. If you subtract 17, then that'd be 5, here 1, that'd be 35, right? So 69 and 35 would be your two values. If you wanted to draw it on a number line for a better understanding there, so this point here was 52. Again, you could have a positive distance going this way. And again, positive distance meaning a positive direction of 17 would give you a point at 69. Or you could have 17, a distance of 17 going in a negative direction, and that point would be at 35. But either way, it's 17 units away. On number 2, point B is between A and C. If AB is 20 and AC is 28, what's BC? So if this is A, C, and B somewhere here in the middle, and the whole thing is 28, and this piece AB is 20. Now that's not to scale, but again, it helps me visualize. So part of it's 20, the whole thing's 28. The other part would have to be 8. I had to subtract. 28 minus 20 gives me 8. That's the other piece of that line. On number 3, what is AM? So the length of AM given M is the midpoint of AB. Well, they told us M is the midpoint. So right away, I know those two pieces are congruent, and therefore they must be equal. So the equation I'm writing is setting those two parts equal to each other. So now, we're solving this. It doesn't matter which way you bring it. I'm going to bring my x values to this side, so subtract 7, and we end up with 5x. I'm going to add the 4 to bring it this way, and we get 20. Divide by 5, and x is 4. 4 is not the final answer. They want AM. So we have to take that 4 and plug it back in. So 12 times 4 minus 4. So that's 48 minus 4, which is 44. That would be our length. Now, this was numbered wrong. This should have been 4 and 5. So this number line is being used for both 4 and 5. First, what's the length of AB? In order to find length, you do the difference and then the absolute value. It doesn't matter what direction you go for this, so we can start from either end. My points here, that one's at 9. This one's at negative 12. So 9 minus negative 12. Now this comes out positive the way I already did it. So 9 minus negative 12, this is really plus a positive. So that would be 9 plus 12, which is 21. Again, it's already positive, so it doesn't matter. If I had written the other way around, we've gotten negative, then the absolute value would change it to positive because distance is always positive. For 5, we're using that distance we just found. So now, point T is between points A and B. The distance between A and T is 1/3 of the length AB. So first thing, 1/3 of that length. So 1/3 times 21, or you could say 21 divided by 3, would be 7. So that's the length of AT. So if we go from A over to T, 7 units, that would bring us to negative 5. Because we're just adding that on to that original value. So negative 12 plus 7 is negative 5. So that's our coordinate for T. All right, 6 is not related to that number line. It gives us some different values here. So AC contains point B. If AB and BC is this, what are write the expression for AC. So these two pieces are the two parts of the overall line. So if you want to, you could draw it out just so you can visualize A, B, and C. This piece, AB, whoops, I put that in the wrong spot. AB is 5x plus 7. BC is 2x minus 2. It wants the whole thing. And it wants it as an expression. So make sure you read the directions. We're just adding these two together. That'd be 7x plus 5. And that's our answer. That's as an expression. Normally, if it wants it as an expression, it's going to say as an expression. So this is the only one on here, I believe, that said as an expression. Everything else should be a numerical value on this sheet. But again, this one asks the key word. It wants it as an expression. So we don't want to find a decimal. We don't want to find a whole number. We don't want to find some fraction. We're just looking for what the expression could be to represent that length. All right? So make sure you read the directions. All right, on the next column. So now this was all from 4.2. This was all about angles. So it starts off, it says that this is an angle bisector. Again, anytime you see the word bisector, it's splitting it in half, just like midpoint. Midpoint means it splits it in half, right? A midpoint is a type of bisector. Here, this is an angle bisector. So it's an angle bisector of ADC. So I'm going to draw an angle first. It always helps to draw a picture. And for your angle, you should always have the middle point as your vertex. So now the angle bisector is DB. So these two are going to be congruent. Your picture doesn't have to be to scale. But now we can label this. ADB is 5x plus 11. BDC is 8x minus 13. They don't give us the whole thing. They don't give us this, right? We don't know that. Do we need to know it for anything? No. We don't want to make something up out there. They gave us enough information to solve this already. They told us that these two are congruent. Therefore, these two values have to be equal. That's going to be our equation. 5x plus 11 equals 8x minus 13. Bring the x's over to one side, so subtract the 5x, you get 3x. Bring the 13 over, add that 13, you get 24. Get x by itself, divide by 3. That's 8. Now that you know x, that's still not our answer because it's asking for measure of angle ADB. So we have to plug it back in. ADB was represented by this expression. So 5 times 8 plus 11. 5 times 8 is 40, plus 11 is 51. And now, this is the measure of an angle, so we should have a unit here. This is in degrees. On number 2, the key word here is complementary. What's complementary mean? Add up to 90. Now, you could draw a picture here if you want to, but really, you don't have to do a picture for this one. You know these two are complementary. They add up to 90. So, 90 equals these two values add together. It doesn't matter if you put the 90 first or at the end. You still end up with the same thing. So we're adding up these two equations. Again, you don't even need parentheses here. I'm just doing it for the sake of showing my work. So I'm adding the two angles, saying it equal to 90. So we'll combine our like terms. 5x and 3x is 8x. 7 and negative 5 gives us 2. So now solve for x. Subtract the 2, you get 88. Divide by 8 and you get 11. They're only asking us for x. They're not asking us for the individual angles. So 11 is all we need. Again, make sure you're answering the question because we didn't have to plug it back in this time. Now, does this get a degree mark? No, because this one is not an angle measure. It's just representing x. If it's just a variable, it doesn't get the degree. If you don't put a degree, yes. Because it's a unit measure. That'd be like saying you wanted to find an answer in feet, but you just put something random and you didn't put whether it was feet or inches or anything. I need a unit so that I know what it's in. All right. So yeah, units. Make sure you put units on the test. All right, number 3. Point D is in the interior of angle CAT. So CAT, I'm going to draw that first. Here's C, here's A, here's T. Then it said D was on the interior, so D is somewhere inside. Don't know exactly where. Doesn't say that these are equal in any way, so we're not going to label anything as congruent. This is 4x plus 1. This one's 23. They give us the overall thing. They say it's 7x plus 3. So we're going to take the two small angles and add them together to get this. That's angle addition postulate. So 4x plus 1 plus 23 equals 7x plus 3. That's a 7. That looks horrible. All right. So now, combine our like terms. On this side, we now have 24 equals 7x. We can bring the 4x over. That'd be 3x. Bring the 3 over, and that's 21. Divide by 3, and that's 7. Now, again, that's x. That's not our answer this time because they want the measure of the angle. So CAT, that's the entire thing. That's the 7x plus 3. So 7 times 7 plus 3. 7 times 7, 49. 49 plus 3 is 52. And again, this is an angle measure, so it's in degrees. Now, for number 4, we again have the word angle bisector. So, if I draw this one, the angle is YXW. An angle bisector XZ. So these two are going to be congruent. They give us WXZ as 3x plus 7. They give us YXW, which is the whole thing, as 11x minus 6. Now, you should know these two angles are congruent. So you could also write the 3x plus 7 here. So we have to add those two together to get this. Or you could say one angle times 2. So you could do a couple different ways. Times 2 equals 11x minus 6. So again, this is 6x plus 14 equals 11x minus 6. Solve for x. Going to bring the 6 over this way by subtracting it. Leaves us with 5x. Bring the 6 over the other way by adding it. Gives us 20. Divide by 5 and x is 4. Again, not the final answer. Got to plug it back in. What are we plugging it in for? YXZ. That's this top one. They didn't originally give it to us up here, but again, it's the same as the bottom one. So we're plugging it into that equation. So 3 times 4 plus 7. That's 12 plus 7, which is 19. Again, this is an angle measure, so it's in degrees. Any questions on the first page so far? Again, I'm going to post this. You can take a picture of it later if you want to as well. But I'm going to post it on Edsby. Oh, I heard wait. Did you need that for another minute? No, we're good? All right. Wait was for something else? All right, on the back. So this was all section 5, activity 5. So now, distance on a coordinate plane. Now, we tied distance on a coordinate plane together with Pythagorean theorem, right? So, on this one, you can do this one multiple ways. You can do your distance formula. And now I'm going to show that as well, because I'm going to post these answers, and I know a lot of people are going to use distance formula. But, is that the easiest method for this one? No. So, yes, I gave you the starting point. You don't have to use it. All right. Now, if you did use it, so I'm going to write it down here. That's my starting point. If you were to use distance, then from that starting point, you traveled 7 miles north. So that means that I'd be adding 7 to my y value. So that'd be a 7 for my y value now. And 4 miles west, which is going in a negative direction. So I'm subtracting 4 from my x value, which should now be 1. So if you wanted to use distance formula, those would be your two coordinates.
I'm confused though. When you do the triangle, how do you know which side is what?
So on here, I'm just going to draw two arrows because I said that I don't really have to use the distance formula for this one. I can just use Pythagorean theorem. Let's say we started at a tree and went 7 miles north. So here's my tree. I went 7 miles north. Then I went 4 miles west. 4 miles west. I need to find the shortest distance back to the starting point, which would be this line here. So that makes a right triangle. I don't have to do distance formula because I have the two legs already of the right triangle. So I can just do 4 squared plus 7 squared, and that should equal this side squared, which if I'm doing it as a right triangle, I'd call c squared. So c squared equals, that's 14. Sorry, 16. I wrote it right, said it wrong. 7 squared is 49. Add it together and you get, let's see, that's 65. Now, I already know this is not going to give me a perfect square, right? So 65, not a perfect square. We're square rooting it. It says round to the nearest tenth, so that should also be a hint that we're going to have a decimal. All right. So plug that in the calculator. Square root of 65 is 8.062225. Now, I rounded it off at some point here, all right? But where am I supposed to round this? Nearest tenth. Tenth is how many decimal places? 1. Remember, when we say tenth, whatever it is, if it's tenths place, 10 has 1 0, right? So that means 1 decimal place. Hundredths place, 100 has 2 zeros, so that would be 2 decimal places. Thousandths place, 3 zeros, 3 decimal places. So 10th. We're going to round it at 1 decimal place, which would be 8.1. And this is in miles, so your final answer should have miles next to it. Now, if you did it as distance, you'd get the exact same thing, right? Because I'm going to show it. Again, it's more work, but our distance formula, plug it in, we'd have 5 minus 1 squared plus 0 minus 7 squared. 5 minus 1 is 4. 0 minus 7, negative 7. And at this point, it should start to look familiar. 16 plus 49, which is then square root of 65, which gives us 8.1. So whether you use Pythagorean or distance, you get the exact same answer. Yeah, I mean, and I know if you've been taught distance and you've used distance and you never knew it as Pythagorean theorem, some people just automatically go to distance formula. But we're going to do lots of triangles this year, lots of Pythagorean theorem. Triangles is like the number one shape that we use all year round. So we'll see triangles forever. Yes.
So for this type of question, distance formula would always work?
Distance formula would always work still here as well, yes. Yeah. Yeah. The problem that a few people had as I was coming around helping people was getting the second point. Because it told you what the starting point was and it was going from there. I think I helped 3 people in here, and everyone that I was helping with this problem did the same thing. They went from the origin. So they said that their original point was negative 4, 7, which would not be correct because, again, you have to go from the point that it told you to start from. So just be careful.
Is there going to be a question like this on the test?
Yep. You will see questions like everything on here on the test. All right. It's actually 18, which is about what you have here. So again, it's oh. How hard do you think this review is? Because whatever you think this review is, then that's what you're going to think of the test. All right? 18. 18. Yeah. All right. Again, I can't recommend this enough, though. On the test, show your work. if you give me an answer, but there's no work, and it's the wrong answer, that's 0 points. Let's just say, for example, each question is roughly 5 points. Right? Because each question is probably going to be about 5 or 6 points. So if you show me no work whatsoever, that's 0 points. But then say you did something like this, and you knew what you were doing. You gave me Pythagorean theorem. I'd at least give you some points for that. You know? Or the distance formula, you plug this whole thing in right. All right? I'd give you points for that, but then you screwed up in your calculations. Or maybe the fact is you gave me the 1 and -4. You went from the origin instead.
Yeah.
But you did everything else right.
Yeah.
I'd give you points. So again, if you just give me a final answer, though, it's nothing. So if you give me a wrong final answer, you don't get any points. If you give me some work, and some of it's correct, then you should get some points. So on a test like this one, it's very important to show your work so that you can get as many partial points as possible. Again, not every test is going to have partial points, but
some of the questions you don't have to do work for.
So like on a midpoint question, for example,
Yeah.
do at least the equation for midpoint show what you're averaging,
Yeah.
because believe it or not, a lot of people make a mistake when they go to add them, they'll subtract them. Or they have it written out right, but then they do something totally wrong just with simple calculations. Again, it happens. When you do the distance formula, there's subtraction in one spot, addition in the other spot, but when they do the work in their head, they switch it around and crazy things happen. Again, show your work and you might be able to get some partial points at least.
Well, how can you show your work on the number line? Like, I mostly just count.
On number lines? Number lines are a little harder, but like for this, I mean, really, that is what I taught you for distance, right? I taught you to do subtraction and absolute value. You could show that first part. You don't have to show any other work after that. And then put 21. At least I can see, hey, you knew what you were doing, and maybe you just added or subtracted wrong. All right? All right. Let's keep going. Number 8 on the back. So, this one, you just have to identify whether or not these two are congruent. Do you have to get all the way down to the final answer, the final numeric value for each of these to do that? Not really. All right. Could you use distance formula? Yes. Could you also use Pythagorean theorem? Yes. There's more than one way to do this. All right. So I'm going to show both. All right. Pythagorean theorem doesn't take much room because here, make that into a triangle, and make that one into a triangle. This is 2 by 1, 2, 3, 4, 5, 6. This one is 1, 2, 3, 4, 5, 6, 7 by 1. So if I wanted to show Pythagorean theorem, so down here for my justification, that would be your work, all right? We have 2 squared plus 6 squared. And I'm going to put an equal sign for right now. I don't know if it's equal or not. On the other side, I'm going to do 7 squared plus 1 squared. So I set my two equations equal to each other because I'm trying to find distance. Is the distance the same? Well, 2 squared is 4. 6 squared is 36. Add those up and you get 40. Well, do I get the same thing over here? 7 squared is 49. 1 squared is 1. Together that's 50. Were those equal? No. So it doesn't work. They are not going to be congruent. Because if I was doing Pythagorean theorem, yes, there's one more step. I'd take the square root of this in the end, right? So if you want to show that as well, fine. But still, that's not the same value. It doesn't work. If you did distance, same thing. I could take my distance formula, set it up. On this one, I have, where are my points here? This is 1, 2, 3. That's at -3 and 3. And this is at 3 and 1. On this one, we have 5 and 4 for that one. And this one would be -2 and 3. So, distance formula. I have -3 minus 3 squared plus 3 minus 1 squared. On the other formula, Same type of thing. 5 minus negative 2 squared plus 3 minus 4 squared. Now, or really, I guess if I used 5 first, I should have used 4 first. Doesn't really matter, the order there. It's going to come out positive anyway. So, on here, what you get? 6 squared plus 4. Whoa, wait. 6 squared plus... I think I typed something in wrong.
2 squared.
Oh, yeah, 2 squared. Sorry. I looked over there, I started cheating. I looked at my 4. It was 2 originally. All right. So then, on this side, that's 36 and 4 and 40. Same work, right? It was just more work setting up in the beginning. Over here, same thing. If I subtract those, I get 7. If I subtract these, I get negative 1. Again, they both get squared, so they become positive. So I get 49 plus 1, which is 50. Again, these are not equal. So whether you do Pythagorean theorem or distance formula, it's the same outcome. They're not equal. So, are they congruent? No. Why? They're not the same length. What's your justification? Your work. All right. All right. Any questions there? All right. Again, you don't actually have to get down to a final number to see that's not the same length. On number 9, what is the distance between the 2 points? Now, this one they gave us 2 coordinates. It's very easy just to plug that into our distance formula. All right. So yeah, I'd probably even use distance formula here just because it's just plug and chug. We got 9 minus negative 2 squared plus 2 minus 4 squared. And always make sure you can read your own handwriting because it can be an issue sometimes. 9 minus negative 2 is 11. 2 minus 4, negative 2. 11 squared, 121. 2 squared is 4. Add them up, that's 125. That's fine for final answer. Alright? It said give an exact answer. Exact values are not decimals that have been rounded. They can be whole numbers, they could be improper fractions, or they could be radicals, or better yet, simplified radicals. We haven't gone over simplifying yet, so I'm fine with that as a final answer. Now, if you remember how to simplify from Algebra 1, and you want to go a step further, this would be 5 radical 5. Again, well, I haven't gone that far yet. We do a lot more simplifying later in the year, and I'll do more simplifying as we go. But again, I'll accept either of these 2 answers because they are correct. All right. Again, if you want to know an easy way to simplify this, what's a perfect square that goes into 125? 25. 25 times what? 5. What's the square root of 25? 5. So that one comes out of the radical. The other one is not a perfect square, so it stays under. That's one way. There's also a factor tree. I'm not going to get into the factor tree right now. I don't know who's first.
But what if you put the actual number answer, not the radical?
It's not an exact value. So you get a point off.
Oh, so if you put 125 on.
Yeah, so if you did like the square root of 125, which is, I don't know what that is. Let's see. Square root of 125 is 1.82. Right? Oh, no. Whoops, sorry. I don't know what my calculator just did. I hit the wrong button. Hold on. In this calculator, I have to hit the second to get the right thing. 125. 11.2. That's a rounded answer. So that's not an exact value. So I'd take a point off for that.
So we only do that when it says an exact answer.
So as an exact answer, you should never round if it says exact answer, right?
That's not a good question. Like, can you write out the formula for that? Because I think I've been doing it all wrong.
This formula?
Yeah, like the.
So distance.
Yeah.
Distance equals the square root of x2 minus x1 squared
Does it matter
plus
what the x you put it first?
y2 minus y1 squared. Now, it doesn't really matter which x value comes first, because when you subtract it, you're going to get the same value. It just would be either positive or negative. So then you can square that number, and you'll get the same thing. Same thing for the y's. So as long as both of these are your x values, and both of these are your y values, no matter the order, it should work out. All right?
Thank you.
Yeah, that's like back here, up here on this one, I actually switched them around. I did you'll notice my 5 and my 3 were not the two that went together for my coordinates, but it still works because the order doesn't really matter there because it's going to become a positive number.
Thank you.
Number 11. This one, now this is all about midpoint, right? So on 11, what are the coordinates of C, the midpoint of AB? Again, midpoint's just an average. You have to average the x's and average the y's. So here, we're going to do -1 plus 5 divided by 2. And then for the y's, 4 and 14. 4 plus 14 divided by 2. Well, 1 plus 5 is... sorry, not 6. I missed my negative. That would be 4, not 6. And this would be 18. So my value would be 2 and 9. Right? On number 12, what are the coordinates of A if M is the midpoint of segment AB? And we know that B is at 3, -5. So, they are looking for the missing endpoint. This is where you could use what I call the snowman method. All right? So, I'm going to make my snowman. Parentheses, parentheses, parentheses. In the top, I'm going to put my first endpoint. Well, the endpoint that I know is 3, -5. In the middle, I'm putting my midpoint, which is -1 and 2. What's the difference here? So from 3 to -1. 4. And it's going in a negative direction, right? If you need to, you could always do the midpoint value minus the original endpoint. So then we're going to go -4 down here as well, which ends up at -5. From -5 to 2, we went +7. So we're going to go +7 again, and now we're at +9. My value is -5, 9. Again, using this method, it's the difference that we had here. You add the same difference here. The difference we had here, same difference there. So again, subtracted 4, so it's subtracted 4 again. Added 7 again. All right? Now, for 13. 13 is a combination of what we did in the last two problems. Because on 13, they asked us for the x value of one of the endpoints and the y value of the midpoint. So for the x value, let's do that one first. The x value, I'm going to do the snowman, basically. All right? Now, I can do it with just one number. It doesn't matter if you have... Yep. It doesn't matter if you have both coordinates or not. I have 4 as one endpoint. I have 11 as the one in the middle. What's my difference here? Would I add plus... Plus what? 7, right? So add 7 more, and you're at 18. That's that missing value for x1. That is now 18. For the y value, we're looking for the midpoint. So we have to do the midpoint of just the y values. So average them. We have 7 plus 13 divided by 2. Well, 7 plus 13 is 20. 20 divided by 2 is 10. So that's the missing y value. So they asked you to do two totally separate things there. One was midpoint. One was looking for an endpoint, so we used snowman. So you had to do both things there. All right. Okay. On 14. So 14, given that AC is 1/4 of AB, find the coordinates of C if you know the coordinates for A and B. Now, think about what we're actually trying to find here. We're trying to find a coordinate value, right? If we do distance, are we going to find a coordinate value? No. If we do midpoint, are we going to find a coordinate value? Yes. So, if we had a number line, or just any line at all, if we find midpoint, that's going to split this in half, right? But then if I do midpoint of those, it splits it up into fourths, so that all those are congruent, right? So what we need here is first, we're going to find a midpoint of AB. Let's call that midpoint M. All right. And then you'd have to find a midpoint of AM, and that would be C. Does that make sense?
Where did it come from?
M, I'm just labeling that as my first midpoint.
How do you know that's like the C not the first midpoint?
Well, it said that AC is 1/4 of AB,
Oh,
right?
okay.
So AC is 1/4 of the overall line. So I just used M. I know M didn't appear anywhere there, but I'm just using M to represent the first midpoint. So to find that first midpoint, M, I'm going to do my midpoint formula using the two values that were given. I have -4 plus 12 over 2. And then I have 5 plus 35 over 2. This is now going to be 8. 8 divided by 2 is 4. This is 40. 40 divided by 2 is 20. Now, I've had a lot of people over the years, including here at tutoring, say, why couldn't I just divide that by 4 and get 210 as my final answer? It doesn't work unless one of those two original points was my origin. All right? Because, again, if it was an origin, it would work. But it's not. These are 2 points that are not the origin, so you can't just divide by 4. All right? So now we have to do it again, because you'll see 210 is not the final answer. All right? So doing this over again, looking for C, I'm using the coordinates of M, which is 420, and A, which is -45. So -4 plus 4 divided by 2, and then 5 plus 20 divided by 2. Well, that's 0. 0 divided by any number is still just 0. 5 plus 20, thank you. 5 plus 20, 25, divided by 2 is 12.5. So we actually get a decimal on this one, but that's fine. That's our final value, 12.5. You could have also written that as a fraction if you wanted to. So you could have left it as 25 over 2. Improper fractions are fine. The last one. All right. It says, we calculate the midpoint M of AB with endpoints. All right, so they give us the 2 endpoints. Is her work correct? Explain using complete sentences. So look at her work. All right, so yeah.
She needs to replace this.
Yeah, so on here, her main mistake, she should be adding those values instead of subtracting them. All right, so you should be able to look at somebody's work and tell me what's wrong. So the explanation, I haven't written anything yet, so her main mistake there is the addition. Again, she used subtraction instead of addition. In order to average values to find a midpoint, you need to add, not subtract. So that's what I'm going to put. To average values for midpoint you need to add, not subtract. Now, another thing that you could do as an explanation is show me the correct formula and do the correct work. That would be a good explanation as well. So if you wanted to put next to it the correct work and show that you don't get that as an answer, that would be another way that you could correct it. All right? But that's it for the review. Again, things to remember for tomorrow. Make sure you are answering the questions being asked. Make sure you use units when you need units. Again, there's not going to be a lot of units, but when we do use units, especially for angle measures, they should be in degrees. On a question like number 7 on this review, you had to put miles. I think those are the only ones that I asked for units for, but I'm not trying to nickel and dime you on every question. But again, if you don't include units and you should have units, I'm probably going to take off a point. All right, so don't be surprised. Yes, this review is for homework, so you need to make sure you turn this in when you come into class tomorrow. You'll turn it into the bin. All right, yeah.
So for 14, how do you know you're supposed to use midpoint? Like, how do you know it's asking you?
So, could you use distance on 14? Yeah, you could, but it'd be really challenging. In order to use distance on there, it'd actually be easier to do distance of the x values and then do like a quarter of it. It would get really messy. But since it's asking for a coordinate point in the end, midpoint is what's giving us a coordinate point, and you can use midpoint twice to do a fourth. All right.